Bismillahirrahmanirrahim. This is another video from Signals and Systems, chapter number 4. And here we'll be discussing example 4.10. And this is on the request of a student. So straight away to the question. Consider again the Fourier transform evaluation of example 4.2 of the signal xt e raised to the power minus at, where a is greater than 0. So let's see what is example 4.2 says. First of all, 4.2 is the same question and it is solved in a manner as discussed here. This infinity, minus infinity to plus infinity according to the definitions, then broken down into two parts, minus infinity to 0 and 0 to infinity. And then using this relation that we got from equation number 1, xj omega, and solving, we find this answer. In this case also we have to find this answer, but using symmetrical property. So this time we will utilize the symmetry property of the Fourier transform to aid the evaluation process. Now in the symmetry property, we will just discuss that if the Fourier transform is xj omega, which is a complex function, then it can be written as the real part of xj omega and imaginary part of xj omega. And if xt signal is real, then these two terms, real term of xj omega and real terms of minus xj omega, will be equal, and this will be called even symmetry. And the imaginary terms of xj omega will be equal to minus imaginary terms of xj omega, and this will be odd symmetry. So just to have an idea, if this is the signal, then its value can be written in this form. And to simplify, we're trying to eliminate the imaginary part from the bottom. So we multiply and divide, multiply by a minus j omega here, and in this case we multiply by a plus j omega, and simplifying we get these two terms. And now you can see that these two terms are equal, the real part of xj omega and the real part of x minus j omega. Therefore, we can call this to be an even symmetry, and that is equal to a over a square omega square. This value. Okay, now as we discussed, this is the even symmetry, this is the value that we were getting, and there are a couple of ways of writing this. We can say that real xj omega is equal to real 1 over a plus j omega. Remember, this is xt 1 over j omega is the transform. So we can write it in this form, and we can write this value. Also, we can say it to be even of xj omega and even of 1 plus a j omega, which is also we can write it to be the real of 1 over 1 j omega. So we'll be using actually these two terms in the next slide. Okay, so EAT we have broken down into two parts when t is positive and t is negative. And you can see ut and u minus t. And I hope you recall that ut is for 0 to positive side, it is ut greater, and from 0 to negative side, it is written as u minus t. The value is 1. And then we simply divide by 2 and multiply by 2. And then we use this formula. So this is for even xt. So we'll apply that here. So it will be 2 times even, EV is even, and e raised to the power at ut from here. And now we had already known this, the transform of EAT-UT, 1 plus E plus j omega. So we'll plug in that. That means even of this, only this part, transform will be even of 1 plus j omega, and even of 1 plus 1 divided by a j omega, as we know, a divided by a square omega square. We'll plug in that. It is real of actually this value, which is equal to a divided by a square omega square. And now it is 2 times, so our final answer will be xj omega is 2 times the real part of this, which is 2 times a divided by a square omega square. So I hope you have been able to follow this. This is slightly maybe tricky, but if you go through it 1 or 2 times, it will become easier, I hope. Please let me know through your comments. Thank you.